तभी तो हीट हो रहा है।
अच्छा ऑयल इन ऑयल
तो ऑयल ऑयल पार्टिकल जल जाएगा तो क्या है, वो तो कंटिन्यूअस हो रहा है। That is one question raised by Mr. Amit Dayal. How do you guarantee that oil below the rotor will push the rotor up during rotation and no contact is maintained? So the hydrodynamic bearing is not developed today. It is a earlier developed and research has been done. Once the metal to metal contact takes place, suppose you don't provide oil, so within minutes all the bearing will burnt out and melted down. The turbine rotor will be damaged and turbine again may come out from the floor. That is a disaster will happen. So that is the idea. It happens. It is allowing no metal to metal contact and we are giving frictional loss minimum is achieved through this dynamic system. By putting off this oil, you cannot test it. It is already happened in the power plant, the damage. If you, by any means, the oil supply is prevented, the accident will be huge. There will be, the casualties will be also there. Next. Any question और कोई क्वेश्चन दिया है? पहले क्वेश्चन जो दिया था वो कहाँ है? पहले का क्वेश्चन सवाल कहाँ है? So, post your any other question from anybody. The rotor part which is moving, the turbine rotor part. So that is that portion is called journal. This is journal. This portion is journal of the rotor. This is the journal portion, and that is the bearing portion. The green one is bearing. Another question from Mr. Gurusaran Singh. When you open the MOT for cleaning, I observed there are many partitions in the MOT. It was not single tank. What are the purpose of this partition in MOT? So you know the partitions, I have shown a single partition over there. Once the oil is gone down and across coming up, so the oil part will come up. The dirt will be settled down. Also the MOT, the bottom is slant. Slightly, it is not flat. It is slightly slant towards the centrifuge side. So the water, the dirt and water particle easily to be shifted one direction, and by particles, the oil will be flow like this and like this. By this way, we are getting the better oil at the auxiliary pump section, where the pumping is being done to transfer this oil. That's why the partition is given, because the dirt oil will to be clean portion, and the after partition, when the oil is delivered to the rear end, there are 2-3 partitions will be there. By cleaning the partitions, already the cleaner oil will be deposited in the extreme end where the pumping is done. Next question. Any other questions? Mic on है? Can we say it for deaeration purpose also? For deaeration purpose, you see the outlet head of the lube oil is very bigger in size. Also the vapor extraction fan, at least one is running continuously. So that is providing cooling and as well as the vapor removal, normal vapor removal from the top of the tank. Sir, at starting it seems that the rotor and bearing are eccentric. Will it be disturb the system? So this is the single shaft. All the generator is a single shaft, that is called tandem compounded. If it's shifted to right side, every bearing will be shifted right side, not the single. It is right side or it is left side. So there is no question of eccentricity. Eccentricity is allowed, a little bit of eccentricity is allowed for hydrodynamic lubrication. This bearing diameter, inside bearing diameter and outside bearing diameter is not same. There is a clearance to provide oil film and oil supply system. So if it is moving right side, so all the length, across the length, all the shaft will be shifted right side only. So lube oil supply pressure is very low. We don't need high pressure oil to be supplied for hydrodynamic lubrication because it is already itself, this rotor itself generating high pressure oil below its surface. That OH developed over here, it is high pressure. So we don't need to supply the high pressure oil. That is the beauty of journal bearing. So Arindam Banerjee has raised a question: where is the duplex filter situated, and is there any thrust bearing filter? Yes, because thrust bearing pad is a load carrying bearing. Suppose mainly thrust bearing is provided over here, right? So we provide a special oil for the filter. So duplex, and for journal bearing, this bearing, high pressure JOP. So after JOP there is a duplex filter to provide very clean oil so that the bearing surface should not damage. So duplex filter is nearby the MOT is provided duplex filter, very high accurate filter is provided duplex filter to provide oil to the thrust bearing and this jacking oil pump, after jacking oil pump. Saurabh Chatterjee, will that high pressure is enough to lift the rotor? Obviously, we design the bearing in such a way that it will create the length, and the bearing is designed in such a way that this beam is capable enough to lift the bearing. Otherwise, it will not run. It will damage within minutes. It will damage. If it is not lifting, it will damage. Sir, I mean to ask, lube oil pressure is becoming lower than the design pressure during turbine running condition. What may be the reason? So running condition, we are providing oil for hydrodynamic lubrication and cooling. Pressure is not important. Pressure means we are allowing some amount of oil. The quantity is important in that case. If pressure, suppose we are providing a pressure, oil pressure, suppose 1.2 kg oil pressure is given. So suddenly pressure goes down 0.6 kg. That means your amount of oil is not providing same oil. So that's why you have to maintain some oil pressure over here to maintain the quantity of oil across the filter. But hydrodynamic lubrication will take place automatically. Next. Any other question? What is the time?
11:21.
Huh?
11:21.
21. So any other questions? Sir, one more question. What is the pressure of EOP? EOP is the emergency oil pump. It will supply the oil as it's supplied by EOP. The same pressure oil will be supplied. It is just to provide you lubrication, to maintain the lubrication, to remove the damage during power failure. Axial displacement. Axial shift, that you can, Ramesh, Chemistry. Question is, axial displacement is always shown in negative sign. Can I know why? So axial displacement means we measure so that is axial shift. If you arrow from this bearing is negative or positive, so it depends upon your turbine. Axial shift takes place because of the turbine balancing system. It's related with the turbine balancing. So if your turbine balancing is not proper, it will give one directional or excels, it may be your case sign is negative. That means the pressure in opposite direction. If we can balance other direction, it may be positive one. So balancing to be checked for this. A little bit of negative, it doesn't matter. It may be positive or negative. It depends upon the balancing of a turbine. Question from Ajit Kumar Singh. If AOP is not developing required pressure, what may be the reason? So you see, if there is a suction strainer inside the pump, it may be choke. Your AOP is not developing pressure. So if it is not developing, another AOP standby will start. So if it is not developing, you check your pump or suction properly cleaned or not. You are once overall one pump, that will give you the required pressure. Next. Are all the bearing in the turbine system journal bearing? Yes, of course. All the bearing is journal. There is no such other bearing. Any more questions from any audience? Is it clear what I have explained to you? What is journal bearing? What is hydrodynamic bearing? What is hydrodynamic lubrication? What is lubrication system? Hope you all understand. From Rohit Kumar, oil header and MOT, that is MOC, not MOT. To change over valve is orifice needed. MOP. See, MOP main oil pump is mounted over here up to 2800 RPM. The oil supply is taken from MOP. Once 2800 RPM process over, the AOP will stop and the MOP will take over automatically. We don't have to change. Automatically it will change over. Please explain hydrostatic action once more. Hydrostatics is very simple. You are providing, suppose, hydraulic pressure to lift the oil. We are giving several oil holes below the bearing and providing high pressure oil to maintain a artificial high pressure oil film to start rolling. So that is hydrostatic lubrication. There is nitrogen cylinder also. What is the use of it, sir? There is. I don't find any nitrogen cylinder in turbine lube oil system. However, the power pack nitrogen cylinder is used in the HPLP bypass system. So it is mainly used when there is a nitrogen bulb is provided inside the tank. So it is compressed condition. So it is a continuous oil, high pressure oil is supplied, can be supplied at any case. So that is a power pack. So nitrogen cylinder is provided in HP bypass or LP bypass system, not in the main oil pump. Gurusaran Singh, sir, can you please, the formula written on the board left off? Yes, I have not explained this little bit of. So the how, that is the friction, and that is one is called Zn by P. One factor that is very important for designing a bearing. Z is the kinematic viscosity. Z is kinematic viscosity. That is viscosity divided by rho. That is kinematic viscosity. It depends on temperature also. Air is the RPM of the rotation. That is turbine RPM. And P is the load carried by the particular bearing. P is the load carried by P. P can be developed by weight for the particular bearing divided by the length of the bearing and diameter into bearing. That is weight divided by area. That is the pressure. Pressure load carried by this bearing. So by this we are plotting how at lower, this is the lower range of RPM where hydrodynamic lubrication doesn't take place. The friction is lower, but it is hunting. It is not stable area. So after a certain RPM, suppose 700 RPM, so we are achieving this much of friction at stable condition. So that is the hydrodynamic lubrication zone we have achieved. So by this curve we are actually designing the hydrodynamic lubrication bearing, and at 3000 RPM, what is the friction zone over here? Ajit Kumar Singh, why oil pressure is different at all bearing in turbine? Maybe pressure is different due to the different size of orifice may be fitted as per the quantity of oil required. See, pressure is not important, the quantity is important. If you reduce the quantity of oil, the bearing temperature will go high. So as per the requirement of the oil for the particular bearing, we design the orifice. After orifice, maybe pressure different. The before orifice, if over means I'm not getting over. If over not working in running condition, what will happen? I'm not getting load formula. And next. Jacking oil supply is already automatically stopped. Jacking oil pump after 6 or 700, as per the manufacturer recommendation. Suppose some turbine maybe 600 RPM, some turbine 700 RPM or something, or some turbine maybe 400 RPM. After 400 RPM, automatically from the speed, the jacking oil pump automatically stop. We don't have to stop. In smaller turbine, we don't see any JFP, right? In smaller turbine, because load is very less, suppose in sugar factory or something or other, that is not required actually. Because this load of 200, 500 and 800 megawatt turbine, this is too much. So in that case, we don't take risk, so we provide JOP. So with this, we thank you very much for today's session, and thank you from NPTI Durgapur.